Graphs with one intercept. There's a bunch of lines that only have one intercept, and so we can't graph them just by showing their two intercepts because there's only one. A vertical line, for example this one, has only one intercept on the x-axis. It doesn't touch or doesn't intercept the y-axis. So a vertical line passing through B on the x-axis has the equation x equals b. So unlike all the other lines which have the equation y equals, vertical line obviously is only related to x, so it has the equation x equals a number. We're letting that number equal b, where b is a constant. That is a number. It is parallel to the y-axis So if anyone says a line is parallel to the y-axis, you know it is a vertical line. And its x-intercept coordinates are b0, where that number is the x-intercept, quite obviously. Obviously, also, horizontal lines are lines with only one axis. Oh, I did not label my line. Line x equals b, and you should always label your line when you are sketching it. So if this is passing through the y-axis at c, this line is y equals c. It is parallel to the x-axis, and the y-intercept coordinates are, of course, 0, c. The equation takes the form y equals c. C is a constant, and it is parallel to the x-axis. And the other type of graph that has only one intercept is, of course, a line that passes only through the origin. The origin, of course, is the point 0, 0, which looks like a little owl face. And there's a whole bunch of lines that go through the origin. For example, this one, which is y equals negative x. And these graphs have the y-intercept of 0, 0. The x-intercept is also 0, 0. The equation of the line is y equals mx, because b, the y-intercept, is 0. And if you are graphing these, you do need to show 2 points. So you would always substitute another value of x, probably 1, or use the gradient, to find one more point, such as this one, 1, negative 1. So you do need to show 2 points on a line unless it's horizontal or vertical. Sometimes those 2 points are the intercepts, but since this only has one intercept, we must show one other point. So if we're asked to sketch the graphs of lines with one intercept, y equals 3. Pick a spot that looks like it could be 3 on the y-axis. Put your straight line through. Mark that your intercept is 3, and label your line y equals 3. Remember that this is x and y, and we use a ruler. X is negative 4. Put a point somewhere that could conceivably be negative 4. Put your line through it, label it, and label your x and y axes and use a ruler. And we've been asked to sketch the graph of y equals 3x. Obviously we have the origin, which is fine, and then we need one more point. Substitute in x is 1, 1, 3. You'll notice because we're sketching, I don't actually need to make sure that I've got a full set of 3 gradations there, but it is a reasonably good idea to make sure it looks pretty good. Now I can say that the point has been shown by marking 1 and 3, or I can do 1, 3. Put your line through, making sure it takes up all of the graph. As I've been doing on these, you don't put this midgetly little line just in the center. Arrows on the end, label it, y equals 3x, label your x and y axes, and use, of course, a ruler. Every so often they might try to trick you and say, excuse the bell there, sketch the graph that passes through a particular point, say 1, 3, and is parallel to the x-axis. In fact, I'll give you a question like that. Passing through 1, 4, parallel to the x-axis. So, because it's parallel to the x-axis, you know it's horizontal, and it has the form y equals c. And so you're looking for the y value in the point, y equals 4, and then you know you're sketching the graph of y equals 4, and you would sketch it like this.